Heat, dust, inhospitable terrain. These plants are a marvel of science, surviving in such harsh conditions. How do they do it? You might think genetics, and you wouldn't be wrong, but there's another force at play, one that has a significant impact on how genes are expressed. It's called epigenetics. Epigenetics? It might sound like a fancy word from a sci fi movie, but it's a fascinating field that helps explain how plants, animals, and even us adapt in different environments. For example, let's say you and your friend both have pantries stocked with ingredients. The food is like your genes, the basic building blocks, but even though you have the same ingredients, you'll probably use them differently depending on what's going on. If you're feeling under the weather, you might grab ingredients for soup. On a hot summer day, you might want some ice cream. Epigenetics focuses on how the environment can impact the way genes are expressed, even though the DNA code itself stays the same. Imagine little switches in your genes. Epigenetics controls whether those switches are flipped on or off. These changes involve chemical tags added to DNA and proteins that package it, called histones. This system determines which genes are active in a cell, affecting how the cell functions and how the organism adapts to its environment. One common switch involves methylation, where a methyl group is added directly to the DNA. Think of methylation as tightening a rope around the gene's instructions. This tightens the grip on the DNA, making it harder for the cellular machinery to access and transcribe the gene. On the other hand, histone acetylation loosens things up. Here, an acyl group is added to the histone proteins, which loosens the grip on the DNA, making the instructions easier to access, allowing for easier transcription. So why is this significant for us humans? Unlike plants in the desert, we don't have to worry about surviving scorching heat all the time, but epigenetics plays a crucial role in our lives, especially during early development. Experiences very early in life, from the environment we grow up in to how we interact with others, can influence the chemical tags on our genes, shaping how our brains develop and potentially impacting our health and behavior later in life. Epigenetics shows us that it isn't nature versus nurture, it's both. By studying epigenetics, we can unlock new ways to promote health, improve development, and even treat diseases. And maybe this is a field you'll explore someday.